All right, so now I've got two batteries hooked up into the same circuit. Let's say this is a 12-volt battery and a 5-volt battery, and three different resistors. Let's go with 2 ohms, 4 ohms, and 3 ohms. All right, whenever you have two batteries, my suggestion to you, remember, it doesn't matter if you get the current the wrong way. If you make a bad assumption about which direction the current's going to go, it doesn't matter. It will fix itself at the end. But my suggestion to you is assume that the bigger battery is going to win the battle. So here, out of this 12-volt battery, my current wants to flow out this way. Let's call this I1. It's going to come down here. That's still I1. Now with this junction, it's going to split. Now, I don't know whether, because this guy wants to send out current also, I don't know if this guy is going to send out current and it's going to flow like that, or if this guy is going to force the current to go backwards through this battery. We don't know. I do because I've done the problem. But in general, you don't know. So just assume that the bigger battery is going to win. Assume that I2 is going to flow this way, I3 this way. So I2 still here, still I2. I3 and I2 combine back together over here to give us I1 again. So at that junction right there, the sum of the currents in equals the sum out. So I1 is I2 plus I3. Again, don't stress. I know I've said this a couple of times. Don't stress whether I2 goes that way or that way. Make a choice and stick with it. If it turns out you were wrong, down at the end, we get I2 equals -3 amps. We know, oh, I drew it wrong. No big deal. It's still 3 amps. I just drew it wrong. We didn't know this is going to turn out right. Okay, now I've got 3 unknowns. I'm going to need 2 loops to give me 3 equations. We could call this equation 1 there. So we pick a loop. Any closed loop. I could do a loop right here, going either direction. I got to pick my direction for my loop also. I could pick a loop in here, or I could pick a loop that goes all the way around. So you pick one. Try to make your loop line up with your current if you can. So I'm going to pick a loop that goes around counterclockwise like that. Call that loop number 1. Not to be confused with equation 1. So from loop number 1, I have a battery that I'm going through the correct way. That's a rise. Going from negative to positive is a rise. That's a 12-volt rise. I go through this resistor the correct way. My loop is going to the left. My current is going to the left. So -2 I1. My loop comes down. Now my loop, here's my loop. It's going in the same direction that I said the current was going in. I said I3 goes this way, my loop goes this way. I'm going through the resistor the normal way. That's a drop. -4 I3. Nothing else on that loop. No other batteries or resistors. So that sum is 0. Okay, let's pick a different loop. You guys want to do all the way around or this little loop in here? Somebody pick one. It won't matter.
Little one.
The little one? Okay, let's say our loop goes like this. Notice I have to pick a direction. If you don't pick a direction on your loop, you're going to get things wrong. So my current is flowing to the right, but my loop up on top is flowing to the left. I'm going through I'm fighting the current. That gives me that a rise through that resistor. So that would be 4 I3, flowing around. My current is flowing to the right. My loop is flowing to the right. I'm going through the resistor the normal way, that's a drop. That would be minus 3 I2. I'm going through the loop is going through the battery backwards. I'm going from high to low. That's a drop. Now I don't have to, remember with batteries, I already know the voltage. It's not V equals IR through a battery, it's just V. So minus 5 equals 0. So I've got 3 equations and 3 unknowns. Now, like I'm a mathematician, I would just solve this by hand. I would take I1 here and plug it here, solve that for I3 in terms of I1, plug that in here, and solve for I2. Now, I would do a bunch of back substitutions. But you guys have all had pre-calc, right? Let's solve this the easy way. Again, if you want to use back substitution, go right ahead. But let's use these fancy calculators we've got. So let's put this in matrix form by writing everything as A, I1 plus B, I2 plus C, I3 equals D. Let's get everything in this form. Write this as a matrix, and then we can just throw it in our calculator. So this first equation is I1 minus I2 minus I3 equals 0. The second one, negative 2I1 plus 0I2 minus 4I3 equals negative 12. And the third one, 0I1 minus 3I2 plus 4I3 equals, when I move the 5 over, 5. That gives me this matrix equation I'm trying to solve. 1, negative 1, negative 1, negative 2, 0, negative 4, 0, negative 3, 4, times my vector, I1, I2, I3, equals the vector 0, negative 12, 5. Again, you guys have had pre-calc. You know how to solve matrix equations. We could find the inverse of this matrix and multiply it by both sides. We could do row operations on this matrix until we get the identity here, and then our solution will be over here. We could do the augmented matrix, where we tack on a copy of this guy here and do row operations. Or we could draw our augmented matrix. 1, negative 1, negative 1, 0, negative 2, 0, negative 4, negative 12, 4, 5. Throw this in our calculator, hit the row reduced echelon form button, and it will spit out our solution. So that's the quickest way. You guys remember all this from pre-calc?
Yeah, I was actually gonna ask you if I could cheese it with reduced row echelon form.
Yeah, and that's by far the simplest way. Or like something we could also do, literally. Type these 3 equations into Wolfram Alpha with commas between them and hit enter, and it will just spit out the answer. Which I'm perfectly fine with. I mean, you guys are engineers. You're going to need to know how to use technology to solve systems of equations. So like literally what I would do if I were writing up the key is I would just type these 3 equations. I would call X, Y, and Z. Type it into Wolfram Alpha with commas in between them, hit enter, and it'll tell me X, Y, and Z. But let's do it using the calculator. Oh, my free trial may have run out on the calculator. I've got two different versions of the calculator. TI. Okay, yeah, this one works. All right, you guys can see my calculator?
Yep.
All right. So we're going to go into matrix here, right there. Type in I lost the word I'm looking for here. Type in this rows by columns, 3 by 4 matrix. So go into edit. Augmented matrix was the word I was looking for. So go into edit. I'm going to call it A. Remember, it's rows by columns, so 3 by 4. And as we type, it will just go to the right instead of down. Remember, this is the negative button. Zero. And then it will go down to the next row. -2, 0, -4, -12, 0, -3, 4, and 5. Okay, now I have a habit of accidentally screwing up my matrix here. So as soon as I type in my matrix, I quit, get out of there, don't accidentally type something over it. And then I want to look at my matrix and make sure I typed it right. So I'll go back into matrix, select A and hit enter and check it and make sure I put everything in right. Okay, it looks good. Now I can come here into matrix again under operations or under math and go all the way down to RREF, row reduced echelon form. And you may be tempted to go, oh, well, here's an A right there. Just do alpha math to get that A. That's the wrong A. In order to grab the matrix, you have to go back into the matrix menu and physically grab it. Hit enter. This part should turn into the identity matrix right here. And then here are our solutions. There's I1, I2, and I3. So let's write that down. So I1 is, we'll round to say 2 places, 2.46 amps. Let me stop sharing. 0.69 amps, and I3 is 1.77 amps. Okay, now again, just for completeness, let me show you a different way to do it. Wolfram Alpha is your friend. I could just type X plus or X equals Y plus Z. So if it's not clear, X is I1, Y is I2, Z is I3. 12 minus 2X minus 4Z equals 0. 4Z minus 3Y minus 5 equals 0. And we get the same answers. Okay, so I am not grading on you on your ability to solve a system of equations by hand. Those days are long gone. Nobody's ever going to make you do that again. Use technology to solve the system.
Thank God we don't have to solve it by hand.
Right. You know, I used to make people do it by hand back when I started doing this because it's really not that bad, especially since it's a take-home test. But you're not going to have to do that in the real world. You're always going to have technology. So, like, I'll get with the times here. You can solve it that way. All right, now we got to write up our solution. So through each resistor, I've got what? This 2 ohm, a 4 ohm, and a 3 ohm. I need V, I, and power. So let's see, through the 2 ohm was I1, 2.46 amps. Through the 4 ohm was I3, 1.77. And the 3 ohm was I2, 0.69 amps. V equals IR to get all the voltages. You guys got your calculators handy? Somebody want to yell these out to me? 2 times 2.46 should be 492, I think.
Yep.
4 times 177. And somebody else do 3 times
7.08.
I'm going to trust you. 3 times 0.69.
2.07.
Volts. Don't forget to put your volt on there. And then power is just voltage times current. So somebody multiply those two. So forth. Somebody?
The first one's 12.1.
So that was probably, actually, this is rounding error. That was probably 12 watts. This is probably 10.
The last one's 1.4.
Is 1.4?
1.4283, but just 1.4.
Okay, close enough.
The second one, I got 12.5.
So this total circuit is spitting out, oh, let's see, that's almost a little over 25 watts. Now, let me ask you guys this. Where can you think of a scenario where you might have 2 different batteries hooked up and you're purposefully forcing current to flow backwards through one of the batteries? It seems kind of dangerous. Why would we do this?
And charge a battery?
Yeah. We have a car hooked up to a battery cables here. We're jumping a car. That's what this does. This will charge this battery or blow it up if it's not a chargeable battery.